All right, 8.5 notes, College Algebra A. Solve quadratic inequalities graphically, and you're going to solve them with the test point method. So 2 different ways of solving quadratic inequalities. Step 1, or beginning here, I want you to remember how to find the vertex and tell me if it's a vertex is a maximum or minimum. Then we're going to sketch it. So remember the vertex is x equals negative b over 2a. So it's going to give you negative 6 over negative 4, which is 3 over 2, or 1.5. Find y would be negative 2 times 1.5 squared plus 6 times 1.5 plus 3. So y is negative 2 times 1.5 squared plus 6 times 1.5 plus 3. So I get 7.5. So my vertex is over 1.5 of 7.5. So right here, my x or my y-intercept is 3. Kind of sketch this graph this way then. So the vertex is a maximum at 1.5 comma 7.5. All right, the next one, vertex is x equals negative b over 2a. So I'm going to write that again, which means negative 8 over 4. So I get negative 2. My y is 2 times negative 2 squared plus 8 times negative 2 minus 1. Use your calculator. So 2 times 4 minus 16 minus 1 gives me negative 9. So back to down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. My y-intercept's negative 1, so I'll kind of draw that symmetrical there. And there you go. So my vertex here is negative 2, negative 9. And it is a minimum. All right, let's go. Find the roots of the above one. So that means find the x-intercepts. The first one will be 0 equals negative 2x squared plus 6x plus 3. So you get x equals negative b or negative 6 plus or minus the square root of 36 minus 4 times negative 6 over twice a negative 4. So negative 6 plus or minus the square root of 36 plus 24, 60 over negative 4. Break that down. So negative 6 plus or minus 2 square root of 15 over negative 4. Simplify a little more, divide by 2. So negative 3 plus or minus square root of 15 over negative 2. Find those two decimals. So negative 3 plus the square root of 15 divided by negative 2.
I'll follow you for a second.
Yeah. All right, we're going to finish these notes on solving quadratic inequality graphically. First, I want to find the roots. I need the decimals of that first one. So negative 3 plus the square root of 15 divided by negative 2. So negative 3 plus the square root of 15 equals divided by negative 2. So one root is negative 0.44. And then the other one is negative 3 minus the square root of 15 divided by negative 2, 3.43. And does that look like those two? So this one would be 3.43 or negative 3 minus the square root of 15 over negative 2. This coordinate point is negative 0.44, which is negative 3 plus the square root of 15 over negative 2. All right, on the other one, let's check it. So let's change colors of pencil. So that one would be 0 equals 2x squared plus 8x minus 1. So x equals negative 8 plus or minus the square root of 64 minus 4 times negative 2 over twice a4. So negative 8 plus or minus the square root of, it looks like 72 over 4. Simplify that, so negative 8 plus or minus, so that divides 36, so 36 and 2. So 6 square root of 2 over 4. Simplify that, divide by everything by 2, so negative 4 plus or minus 3 square root of 2 over 2. So let's get the two decimals of that. Negative 4 plus 3 square root of 2 equals divided by 2. So I have one decimal at 0.12. And then the other one is negative 4 minus 3 square root of 2 divided by 2, negative 4.12. So this would be the 0.12, which is negative 4 plus 3 square root of 2 over 2. The coordinates of that point will be negative 4.12, which is negative 4 minus 3 square root of 2 over 2. All right. Step 1 through 6, when you're solving graphically, set it equal to 0. Replace the inequality symbol with equals. Find the vertex. Sketch the graph. Find the roots. And then write the solution based on your graph to the inequality. All right, so step 1, set it equal, or move it over to one side. So I get x squared minus 8x plus 15 is greater than 0. Step 1 done. Replace the inequality symbol with equals. So x squared minus 8x plus 15 equals 0. So next step says find the vertex. So vertex is x equals negative b over 2a. So 8 over 2, which gives me 4 for the x. Let's write that formula out. So this is the vertex. X equals negative b over 2a. So 8 over 2, which gives me 4. My y then is, substitute that back in. So 4 squared minus 8 times 4 plus 15. So 4 squared would give me 16 minus 32 plus 15. So negative 1. So my vertex is over 4, down 1. I can see my y-intercept is up here at 15. So I can see that this graph's going to do something like this. All right, find the roots. So when I find the roots, that means set that equal to 0. So roots will be x minus 3, x minus 5. We can factor that, so let's use that. So my roots are at 3 and 5. So this is 5. This would be 3. So then I need to answer my question, and I need to know when this graph is greater than 0. So it's greater than 0. Let me use yellow here. So it's greater than 0 from here to here, there to there. So my solution set then is, I would say from negative infinity. Let me make that better. I'd say negative infinity to 3 with a parenthesis. It doesn't equal union 5 to infinity. All right, number 2, step 1, set it equal to 0, or it is. So we're good that step. Replace that. So I get negative x squared plus 3 equals 0. So remember what this graph is. Negative x squared plus 3 means I go up here to 3, and this opens down, because the negative here makes this graph open down. All right, so now we have to find the roots. So that would be, negative x squared plus 3 equals 0. Let's minus 3. So negative x squared equals negative 3. So x squared is 3 which means x equals plus or minus the square root of 3. And the square root of 3 is approximately plus or minus 1.73. So I can see I have an x-intercept here of 1.73, which is square root of 3. And this one will be negative 1.73 or negative square root of 3. Alrighty, and so now the question is, where is this graph greater? So I want to know when this graph is greater than 0. So this graph is greater than or equal to, greater than or equal to 0 from there to there, which means my solution then is bracket negative square root of 3 until square root of 3. All right, next one. Step 1, we're good. Step 2, set that equal to 0. So x squared minus 2x minus 1 equals 0. Find the vertex. So you'd have x equals negative b over 2a. So I get 2 over 1, which is 2. Y would be 2 squared minus 2 times 2 minus 1. So 2 squared is 4. 4 minus 4 is 0. So you get negative 1. So my vertex is over 2 down 1. Which that cannot be. Let's try that again. Negative b over 2a. Oh, that should be over 2. Giving that a 1. So that's a 1 squared minus 2 times 1. Let's see what that gives us. So 1 minus 2 is negative 1 minus 1, so I get negative 2. So over 1 down 2, that makes more sense. Alrighty, so that's my vertex. This thing, positive, so this opens up. My y-intercept's negative 1, so I see it as this. All right, so I found the vertex, opens up. Now we need to find the x-intercepts, or the roots. We can't factor that, just looking at it. So you're going to use quadratic formula. X equals 2 plus or minus the square root of 4 minus 4 times negative 1 over twice a2. So 2 plus or minus square root of 8 over 2. So 2 plus or minus 2 square root of 2 over 2, which simplifies to 1 plus or minus square root of 2. Let's find the 2 decimals on that. So 1 plus the square root of 2. 2.41, so that is this number here. So this is going to be 1 plus the square root of 2, comma 0. And then 1 minus the square root of 2. Negative 0.41 would be this one. So that point is 1 minus the square root of 2, comma 0. So the question says, when is this graph great or less than 0? So I'm interested from here to here, which makes my solution parentheses doesn't equal 2. So parentheses 1 minus the square root of 2 until 1 plus the square root of 2. All right, number 4. It's already set up correctly, so let's find the vertex. X equals negative b over 2a, which gives me 8 over 2, or 4. My y value will be 4 squared minus 8 times 4 plus 16. So I have a 16 here, and a 16 minus 32, so it looks like 0. So I'm going to sketch this graph over 4 up 0, and this graph opens up. So if I were to find the roots of this one, you set that equal to 0. So x squared minus 8x plus 16 equal to 0. So that factors to x minus 4 quantity squared equals 0. So my root is x equals 4, which is that point right there. So when is this graph less than or equal to 0? Well, it's never less than 0, but it's certainly equal to 0 at 4. So my solution is one number of 4. It equals 4. So it's equal to right there. All right, next one. X squared plus 2x plus 3 greater than 0. So let's set it equal to 0 first. So x squared plus 2x plus 3 equals 0. So my vertex is x equals negative b over 2a. So negative 2 over 2, which gives me negative 1. My y is negative 1 squared plus 2 times negative 1 plus 3. 1 minus 2 is negative 1 plus 3 gives me 2. So if I sketch this, my vertex is over or back 1 up 2. My y-intercept is 3, so over here. All right, so just looking at this graph, when is it greater than 0? Well, all the time. Now let's say you don't trust that and you're like, I better make sure these roots are non-real. So my roots would be x equals negative b, so negative 2 plus or minus the square root of b squared, which is 4, minus 4 times 3 over 2. So you get negative 2 plus or minus the square root of 4 minus 12 is negative 8 over 2. So we have non-real roots, which tells me it has no x-intercepts. So my solution is negative infinity to infinity. It's always above 0. All right, last one here. Set that equal to 0 first. So negative x squared plus 4 equals 0. Or minus 4, sorry. So this has a y-intercept of negative 4. Negative x squared means it opens down. I don't know if we need to do any more. When is this graph greater than 0 or equal to? You would say never. So my solution is no solution. Does not meet the x-axis. All right, the next set of these, solving quadratic inequalities with the test point method. We're going to test points on this one. Rewrite the inequality with 0 on the right. Results, replace the equal sign, inequality sign with the equals. Replace the inequality with equals. Locate the solutions to the quadratic equation on a number line. Select one test point in each interval. Check whether it works in the original inequality and write the solution. All right, example 1. It's already got the 0 on the right, so we're going to do x squared minus x equals 0. So all we're interested in this time, solving this equation. So we're solving for x. So we can factor this, x minus 3, x plus 2 equals 0. So my x-intercepts or my roots are 3, negative 2. So what you'll do is go to a number line here. So here's negative 2, negative 1, 0, 1, 2, 3. So I have numbers to the left of negative 2 and numbers to the right of 3 and numbers in the middle. So I'm going to test points. I'm going to look at these numbers here. We don't want to use those. We have to choose numbers in those intervals. So let's look at, in this interval here, let's choose maybe negative 5. In this interval, let's choose 0. And here, let's choose positive 5. So I'm going to do a check here. Go back to the original. Tell me if it's true or false. So negative 5 squared minus negative 5 minus 6, is that less than or equal to 0? So this gives me 25 plus 5 is 30 minus 6 is 24, so this is false. So that's not true. Put in 0, so this is negative 5. Now let's try 0. So 0 squared minus 0 minus 6, is that less than or equal to 0? Yep, that's true. And then the 5, positive 5, so 5 squared minus 5 minus 6, so 25 minus 11, is that less than or equal to 0? That is false. So my solution set, what's true, is everything in here, and it's equal to, so I'm going to put a bracket here. So my solution set is bracket negative 2 to 3. All right, number 2. You write it first. So x squared minus 4x minus 6 greater than 0. Set that equal to 0. X squared minus 4x minus 6 equals 0. We can't factor that, so quadratic formula. X equals 4 plus or minus the square root of 16 minus 4 times negative 6. twice 8, 2. So 4 plus or minus 16 plus 24 gives me 40. So square root of 40 over 2. So square root of 4 is square root of 10. This gives me 4 plus or minus 2 square root of 10 over 2. So 2 plus or minus square root of 10. All right, we're going to write our number line here. But let's get some decimals here. So 2 plus the square root of 10 is 5.16. And 2 minus the square root of 10 is negative 1.16. All right, so let's get some estimate here. Here's 0, 1, 2, 3, 4, 5. So a little bit more. So 2 plus the square root of 10 is here, approximately. And negative 1.16. 2 minus the square root of 10 is about here. All right, so let's look at some intervals. Let's choose some numbers. We can definitely say over here, let's do negative 5. In the middle, we can choose 0. And this side, we could choose, let's say, 10. So let's do some check, see what's true and false. So let's do negative 5, 0, and 10. So negative 5 gives us, go back to the original one, negative 5 squared minus 4 times negative 5. Is that greater than 6? So 25 plus 20, is that bigger than 6? That's false. Put in 0 is 0 squared minus 4 times 0 greater than 6. Oh, wait. That's false. So the first one, let's look at that again. I'm probably not adding right. So 25 plus 20 is 45. Oh, that's true. Sorry. 10, so you have 10 squared minus 4 times 10. Is that greater than 6? So 100 minus 40, that is true. So this side here is true. And this side is true. So my solution set is, and they, oh, parentheses. Let's do parentheses this time. Parentheses this time. Oh, go to here. So my solution set is, we're going to go negative infinity to 2 minus the square root of 10, union 2 plus the square root of 10 to infinity. A couple more examples here. So set it equal to 0 first. X squared plus 6x plus 10 equal to 0. Find your x-intercepts. So x equals negative 6 plus or minus the square root of 36 minus 4 times 10 over twice 8, 2. So negative 6 plus or minus square root of negative 4 over 2. Negative 6 plus or minus 2y over 2. So no real solutions here. So let's think about this. If I have a graph, I have a y-intercept of 10. I can see that. Let's kind of get an idea. So my x-intercept, or my vertex, would be negative b over 2a, so negative 6 over 2. So my vertex starts here at negative 3. So if I do that, so 3 squared is 9, minus 18, plus 10, I get 1. So negative 3, 1, it's here. So this thing opens up. So where is this thing greater than or equal to 0? So if we're choosing test points here, let's just test 0. Is 0 plus 0 plus 10 greater than or equal to 0? That's true. So if 0 is true, then everything is true. So my solution is everything, which means negative infinity to infinity. Last one in this set, 3x squared minus x minus 4. I'm going to less than 0, set it equal to 0. So 3x squared minus x minus 4 equal to 0. Find your x-intercepts. X equals 1 plus or minus the square root of 1 minus 4 times negative 12 over twice a 6. So I get 1 plus or minus, that's 48, square root of 49 over 6. So 1 plus or minus 7 over 6. So 8 over 6 is one answer, which is 4/3. And 1 minus 7 is negative 6 over 6, which is -1. All right, so we don't want to sketch it this time. So my number line will be here at -1. Here's 0. A little bit more than 1 is your 4/3. So I'm interested in what's happening here. So my test points, let's choose -2, let's say, 0, and let's do +2. So let's do a check of those. So let's use -2 first. So 3 times -2 squared minus 4, is that less than -2? So -2 squared is 4 times 3 would be 12. 12 minus 4 is 8. Less than -2? No, that's false. Let's try 0. 3 times 0 squared minus 4, is that less than 0? -4 less than 0, that's true. Try 2. 3 times 2 squared minus 4, is that less than 2? It's going to give you 12 again minus 4, 8. That's also false. So it's true where 0 is at, which means it's true in here. So my solution set is parentheses -1 to 4/3. All right, last handful here. So rewrite this: 1/2 x squared minus x minus 12 is less than or equal to 0. Ooh, let's multiply everything by 2, make this easier. So I get x squared minus 2x minus 24, still less than or equal to 0. Set it equal to 0. X squared minus 2x minus 24 equals 0. So my x-intercepts are -6 and 4. No, x minus 6x plus 4, we factor it. So my x-intercepts are 6, -4. So here's -4. Let's look at 6. All right, so let's finish this one. Let's look at a point here. Let's say -6. So when x equals -6, let's put it into the first equation there. So 1/2 times -6 squared. So -6 squared would be 36 times 1/2 would be 18. So I'm putting this back into the first equation. So 18 less than or equal to -6 plus 12. Is 18 less than 6? That is a no, so not true there. So let's choose a number in the middle here. Let's say 0. So when x equals 0, I have 0 on this side. Less than or equal to 0 plus 12. Is that true? 0 less than 12, yep. And then let's choose a number up here. Let's say 10. 10 squared is 100. 1/2 of 100 would be 50. So is 50 less than or equal to 10 plus 12? The answer is no. So I can see it's correct from -4 to 6. So my solution set would be bracket -4 to 6. And bracket because it says equal to. All right, number 2, x squared greater than or equal to this. So let's do x squared greater than or equal to 4x plus 12. So we're going to go x squared minus 4x minus 12. Let's put that equal to 0. Find those x-intercepts. Can we factor that? Yeah, let's factor. So x minus 6, x plus 2 equals 0. So my x-intercepts are 6, 0, and -2, 0. So let's look at this. I'm going to graph this one. So let's look at -2, 0, and 6, 0. We know this is a parabola that opens up. So then where is this graph? Let's make this greater than or equal to here. So where is this graph greater than or equal to 0? You would say from -infinity until -2 with a bracket, union bracket, 6 to infinity. Let's do a check on one of those just to see. So let's do a check that it's, let's do an area where it's not true. Let's say x equals 0, so it should be not true there. So is 0 greater than or equal to 4 times 0 plus 3 is 3. 0 bigger than or equal to 12, that is a no. So 0, 0 not true, that means these are true. All right, number 3 in this set, we have x squared is less than 6x minus 9. Let's move everything to the left. So x squared minus 6x plus 9 less than 0. Let's set it equal to 0. So x squared minus 6x plus 9 equal to 0. Let's factor that. We can. So x minus 3, x minus 3. So my x-intercept is just 3, 0. Let's graph this thing. So 3 zeros here, so we can see this thing opens up. It's a positive x squared. All right, and we want to know where this graph is less than 0. Well, it is never less than 0. It's equal to 0, but it doesn't say equal to, so my solution is no solution. Last one here, so let's say negative x squared plus 10x, let's rewrite it, minus 28 less than or equal to 0. So let's factor out a negative here, so which means I get x squared minus 10x plus 28. Can I factor that? No, so I'm going to undo this. Let's do vertex. So the vertex is x equals negative b over 2a. So negative 10 over negative 2, which means I get 5. My y then will be negative of 5 squared plus 10 times 5 minus 28. So that gives me negative 25 plus 50 minus 28. So that'll give me a 25 minus 28, so I get negative 3. So my vertex is 5, negative 3. And this has a negative to start it, so that means this thing opens down. And the question says, when is this graph less than or equal to 0? You would say this is always less than or equal to 0, so the answer is negative infinity to infinity.